DC supply into AC supply, that is achieved with the help of inverter. That inverter output is given to the AC motor. If it is DC motor, here no need of inverter, the structure will be very simple. So I will tell the advantages and the drawbacks of the motor side also. So anyhow, this is the structure of the battery pack. So here we have to charge the battery. So for that there are two options. First one, you have to charge the battery with the help of fuels, as well as we can charge the battery with the help of input AC supply. That means plug-in AC supply. So now we can discuss about the plug-in AC supply. So what are the drawbacks are available in the plug-in AC supply? Actually the battery is DC operation. For this battery we cannot provide AC, because if you provide AC supply to the battery, in positive cycle it will get charged and in negative cycle it will get discharged. So it is not possible to operate the battery with AC. This is the reason. In positive cycle it will get charged 0 to 180 degree, and in 180 to 360 degree it will get automatically discharged. So total voltage will be 0 voltage. So for charging the battery, definitely we have to provide the DC supply only, but we know the input supply of our houses, that is AC supply, alternating current at 230 volt with 50 Hz frequency supply. That means the positive cycle having 10 milliseconds and the negative cycle having 10 milliseconds, cumulatively 20 milliseconds. That means 0.02 seconds. From this 0.02 seconds, frequency is 1 by T. So 1 by 0.02 will come 50 Hz. So if you provide this 230 volt 50 Hz supply to the conventional diode bridge rectifier, so we know the working of diode bridge rectifier, that will convert the AC supply into DC supply, but it will create the problem in the input AC side. That means the diode bridge rectifier creating harmonics in the input side. So we have to know what is harmonics. So harmonics means integer multiple cycles of fundamental frequency actually. Suppose your input is 50 Hz and the output of the diode bridge rectifier is like a full wave rectifier output. That means it's having only positive cycle, so that your time is 10 milliseconds only. If input is AC, it's having both these positive cycle and the negative cycle, so 20 milliseconds. If you see the output of the diode bridge rectifier, it's only in positive cycle, so the total time is 10 milliseconds. So from the 10 milliseconds, if you calculate the frequency, we will get 1 by 0.01, we can get 100 Hz. That is the harmonics actually. Secondary harmonics is a little bit only, but anyhow, so what is harmonics means? Integer multiple cycles of fundamental frequency. And it's creating the distortion in the input current. So that means your power factor is going to reduce. So what is the impact of power factor in the input side? So we know the power. Actually in power there are the total power is apparent power. That apparent power is the combination of real power and reactive power. In real power, for 3-phase, the formula is we know 3 VA cos phi, and for reactive power 3 VA sin phi. In single phase, the real power is P is equal to VA cos phi, and then another one reactive power is VA sin phi. First, suppose if you take, and another one, the battery is not a linear load, it comes under non-linear load. So if you charge the battery, so definitely the power factor problem will come. How means both the voltage and the current will not be in phase. The voltage will start from 0, but the current will lag with the voltage. So it may be 0 to 90 degree difference will be there. So depends on the particular angle. If you calculate the power factor, so this power factor means cosine of the angle between voltage and the current. If your load is linear load, then the angle difference between voltage and the current is 0, then you will get unity power factor, because cos 0 is 1. But under battery load, it is not possible. Definitely it will affect the power factor. So it will come around 0.7, 0.8, less than 0.8 it will come. So if you use diode bridge rectifier, this kind of problem will come. The real power will decrease and the losses, it will generate, reactive power will increase. And it will affect the battery also, and it will affect the nearby load also. So definitely we have to omit this kind of battery charger. That means conventional diode bridge rectifier based charger. So next one is power cycle connection based converter, PFC converter. So and before that, before PFC converter, this diode rectifier is creating voltage sag problem also. That means completely it's creating power quality issues and it's affecting the input source. So in order to overcome the problem, we have to go for PFC based converters, means power factor, PFC boost converter, PFC step converter, interleaved converter. So many converters are there. This converter can maintain unity power factor operation. But still, it's creating power quality issues only. We can omit it, that is not a problem. And again, you have to charge the battery from AC supply. I think you know about the tariff of the EB supply now. It's increased. So in 2021, in my office, for the same load, the EB bill is only 18,000. Now it comes around more than 40,000 rupees. So we have to consider the EB bill also. So the best solution is now, the best one is renewable energy based electric vehicle is the best one. So these are the drawbacks of the conventional electric vehicle. First one expensive, second one this one causing the battery, it creates a problem in the battery side as well as input side. Then regularly you have to replace the EV batteries also. It's a challenging work. Then here also emission of carbon is there. So the best solution is renewable energy based electric vehicle. So under the renewable energy resources, we know so many sources are there. The first one is solar and the second one is wind energy conversion system, then biomass, so many things are there. But for electric vehicle application, wind energy conversion system is not a good one because wind energy conversion system is not a primary source, it's a secondary source. First we have to provide supply to the stator, then only we can get the power, we can generate the power from the either stator as well as rotor. So wind energy conversion system is not a good one for electric vehicle. And the fuel cell, the cost of the fuel cell is very high. So the best and the effective solution is in the under renewable energy system, PV only, photovoltaic system only. We know that we are working on the PV system, it's converting the sunlight into electricity. Solar panel depends on the two inputs. First one is temperature and another one is intensity. These two parameter changes means automatically your output voltage of the solar panel will vary. It's not possible to extract maximum power from that particular PV system. And another one is if you arrange the solar panel in rooftop, definitely partial shading problem will come. So we have to consider these all issues. So for that we have to go for first we have to maintain, that means we have to stabilize the output voltage. So we need one DC to DC converter and with the help of FPPT algorithm. So shortly it is known as charge controller. All of them know about the word charge controller. That charge controller consists of DC to DC converter and on that algorithm, maximum power point tracking algorithm. These two will achieve MPPT, maximum tracking the maximum power from the PV system. So next one, by using this converter, we can store the battery. We can charge the battery. For that, we need one bidirectional DC to DC converter. That means during night time, it is not possible to get the power from the PV system. So during daytime, we have to charge the battery. During night time, that battery should recharge. That means it could be discharged the output power to the motor. So during the daytime, suppose I will tell one example, your input is 12 volts, that means from the PV panel we are getting 12 volts, and the EV motor, suppose if you take any DC motor or AC motor with a 48 volt rating, we have to amplify the DC voltage from 12 volts to 48 volts, same time we have to charge the battery. So during the storage system, means during charging, instead of taking the output from the solar panel, we can take the output from the converter output, because solar panel output is varying, but the converter output is constant because of the FDP algorithm or some closed loop controllers. So that 48 volt output is given to the battery converter. During daytime, that battery converter, bidirectional converter will work under work mode. So the 48 voltage has stepped down into 12 volt, then it is stored in the battery. During night time, that 12 voltage has stepped up into 48 voltage, that voltage is fed to the motor. So this is the way battery based electric vehicles are working with the help of PV based supply. Here also you have to think, by charging the battery, it needs additional power from the PV system. So in this work I am suggesting, actually this is the PV based electric vehicle architecture. The PV output is given to the battery pack and the pack output is given to the power converter. The power converter is again amplifying the voltage. If it is AC motor, how to convert the DC into AC, or else directly we can provide the DC supply. So these are the drawbacks of the PV based and battery backup based electric vehicles. So the first one, the lifetime of the battery will decrease and the number of batteries requirements are high. So it's not possible to connect all the batteries in parallel. So it will be in series. We know about the problem of the series connection. In between, if any battery is not working means, so again we have to go for proper maintenance. So these are the drawbacks of the battery based electric vehicle. So next I will explain about the PV based grid-tied electric vehicle. So better you can consider the example of the electric train. I am not telling about the car as well as bus. You can take the electric vehicle as a train, locomotive applications. In the electric vehicle, that means in the train, you can arrange in the roof, you can arrange the solar panel. So from the solar panel, we can take the power. That power we can inject into the motor during daytime. In the solar panel, if we arrange the solar panel, from 3 to 4 compartments, we will get the sufficient power to run the motor. The excess amount of power we can give it to the grid during the daytime. At night time, we can take the power from the grid. That power is given to the electric vehicle. So under this concept, no need of batteries. So this is the efficient, one of the good advantages for electric vehicle system. That means grid-tied electric vehicle system. So this is the structure of the grid-tied electric vehicle system. The PV panel output is given to the power converter. Similarly, with the help of inverter, we are providing to the electric motor. That excess amount of power is given to the single-phase voltage source inverter, as well as you can use three-phase inverter also. That inverter will convert the DC voltage into AC. With the help of proper grid synchronization, we can inject the power into the grid. During daytime, we can give the power to the grid. During night time, that AC is converted into DC. I will explain this concept later. That DC voltage is given to the three-phase inverter. That inverter will convert the DC into AC during night time. So these are the advantages of the PV-based grid-tied electric vehicle. So first, it does not require any storage system. So maintenance is very less, and then we are fixing in the rooftop of the train. So by 3 to 4 forces is enough to provide the power to the engine, and the remaining amount of power we can do to the grid. So these are the advantages. Now I will explain one by one about the general block diagram for this work. First, the input is PV panel. That PV panel output is given to the DC to DC converter. So here I will explain 3 to 4 converters. Then I will explain about the difference between the FDP algorithm and the closed loop algorithm. That DC to DC converter output is given to the two-phase voltage source inverter. That inverter output is given to the VLDC motor, brushless DC motor. Then first I will start from the controlling technique. So what is the need to control the DC to DC converter? So already I told, from the PV panel you will get fluctuated output voltage. That means non-regulated DC output voltage because of the temperature as well as intensity variation. That output is given to DC converter. So before studying the electric vehicle, we have to know about the grid-tied PV system. For grid-tied PV system, there are two systems are there. First one is transformer-based grid-tied system, and another one is transformer-less grid-tied system. So in solid state drives, these kind of topics are there actually. In the first one is transformer based. That means that the 12 it is available in the home UPS. That the 12 voltage output is given to inverter. That inverter will convert the 12 volt DC into 9 volt AC. Then we have to step up the 9 volt AC into 230 volt AC. We have to think about the power losses. Right? It is too high. So the best solution, and another one problem is leakage reactant. So best solution is we have to go for transformer-less system. For transformer-less system, first we have to fix the DC link voltage. If your grid is three-phase grid, the AC voltage is 415. So into root 2 times we have to fix the DC. So minimum 600 volt DC link you have to maintain for three-phase supply. If it is your grid is single phase, then 230 into root 2 again, almost 300 volt to 330 volt DC you have to maintain. So anyhow, for input, that means for inverter we have to provide the input. If your inverter is three phase, then we have to maintain 600 volt DC, or else we have to maintain 300 to 330 voltage DC link for single phase. Okay. But we know the problem. From the PV panel under short circuited condition, we are getting 12 volt only. That 12 voltage is given to the inverter means you will get only 9 volt. So here you have to think about the DC link voltage is 300 volt. For this, we have to connect 25 number of solar panel in series. For example, we are taking 100 watts panel with having 12 volt supply. Each panel having 100 watts and 12 volt. If you connect these 25 solar panels in series, the cumulative voltage you will get around 300 volt, but the power will be same 100 watts. The voltage is increasing, but the power remains same 100 watts. No use. Only out of 2500 watts, you are tracking only 100 watts. Your efficiency is very, very less. Correct? So for that, we have to increase the number of solar panels should be connected in parallel. That's why we are in need of DC to DC converter. First, let us take one boost converter. We know the circuit of the boost converter consists of one inductor, one capacitor, one diode and one switch. That inductor and capacitor will store the energy. At the same time, it will reduce the ripple conduct from the input because that is LC filter, single order low pass filter. It can reduce the ripple conduct in the PV panel output voltage. And the second one, the function of inductor. We know the basic concept of the inductor. It is an energy storage element. That means it stores in the form of electromagnetic energy. The kinetic energy is 50%. So for example, if you provide a 12 volt input to the boost converter, you will get around 18 volts, but you have to maintain nearly 98% duty cycle of the converter. That means switching stress as well as switching loss is very, very high. In conventional DC to DC converter, first it's having one inductor and capacitor. Passive losses are very limited only. But the gain, voltage gain of the conventional converter is very, very less. That means your input is 12 and output is 18. So what is the gain? Gain is V0 divided by V in. So 18 divided by 12, you will get around 1.5 times. And if you take the structure of the boost converter, in input side next to the DC source, inductor is there. But in the output side, diode is there. So here input current is continuous, but output current is discontinuous in the boost converter. So the efficiency wise it will provide good efficiency, but the drawback, output current is discontinuous, still it will affect the converter output current and efficiency. So this is the drawback of the boost converter. So in this case, same you can take the 30 number of solar panels. From the 30 number of solar panels, you can connect 20 number of solar panels in series and another 10 number of panels you can connect it in parallel. Because I told you now, this voltage gain is 1.5. So before that, without any DC to DC converter, only 100 watts is possible. Now you can think about that we can provide around 1000 watts because 10 number of solar panel is connected in series. That means parallel. So almost 1000 watts power you can give to the load. This is not enough now. Out of around 3 kilowatts, only 1 kilowatt power we are providing to the converter. That means load. So it is not enough. Next one, controlling the DC to DC converter. For controlling the DC to DC converter, there are two methods are there. First one is MPPT algorithm. Second one is closed loop controller. So many of them thinking about the MPPT algorithms are under open loop, or it's not open loop. It comes under closed loop only. So we studied the open loop system and the closed loop system in control system. If any feedback is there, that system is known as closed loop system. For MPPT algorithm, we are taking the reference from input side. That means we are extracting the power from taking the voltage and current. That means we are sensing the VPV and IPV. That means from solar panel voltage and solar panel current, we are finding the power. That means how much power we can able to give to the load. And another 10 milliseconds, again we will get some another change in power. So first one is called as actual power. After 10 milliseconds, we are getting the change in power, that is called reference power. So if we compare these to reference power and the actual power, we will get error. That error is given to the algorithm. So that algorithm will compare the duty cycle. That means it creates a duty cycle. Actually, to generate the PWM pulse, we need two signals. First one is the carrier signal and another one is the reference signal. So for DC to DC converter, the carrier signal is we can use the 10 kilohertz. That means the triangular signal is the best one. Here reference signal is initially you have to fix 50% because all the buck boost type converters will work under both buck as well as boost mode. So at less than 50% duty cycle, the converter will work under buck mode. So more than 50% duty cycle, it will the converter will work under boost mode. So initially we are maintaining 50% duty cycle. Then after that, this VPV, through VPV and IPV, we are generating the reference power. That reference power and the actual power we are comparing. That error is given to the particular MPPT algorithm, which may be P and O, incremental conductance, physiological algorithms, or neuropathy, or any other intelligent controller you can take it. That controller converting the high value of power error into less than 1. So Y means the amplitude of the carrier signal is 1 volt. If you are not use any MPPT algorithm, suppose your reference power is 1000 watts and the actual power is 900 watts, the error will be 100. So it's not possible to compare the 1 volt carrier signal into 100 volt reference signal. So in order to convert the high value of error into less than 1, we are using MPPT. So this is the way we are generating the reference signal. That reference and the carrier we can compare. The error is called the duty cycle. That duty cycle is given to this particular converter. This is MPPT algorithm. We are not taking any feedback in the output side. Only input side we are taking. That means voltage stability is not possible. But power stability you can achieve in the MPPT algorithm. So for standalone load, MPPT algorithm is very suitable. But grid connected or BLDC motor side application, from my point of view, closed loop controller is best. Why means in closed loop controller, the reference voltage you have to assign. So how much DC voltage you have to maintain. That reference voltage and the actual voltage from the converter is compared and the error is given to the conventional PI controller, proportional plus integral controller. That error is given to the PWM generator. In PWM generator, again the carrier signal and reference signal we have to compare. That error is duty cycle, we can go to the DC to DC converter. So this is the difference between the MPPT algorithm and closed loop algorithm. In MPPT algorithm, it's not a open loop system. That also closed loop system only. In MPPT algorithm, so first you have to take the feedback from the PV side. But in closed loop controller, you have to take the feedback from output side. This is the difference between MPPT and closed loop controller. In the conventional PI controller, how it's generating means how it's controlling the converter. Suppose, for example, we are providing 100 volt input to the converter. Our aim is we have to maintain 300 volt. The converter having 10 times, that can boost up to 10 times. So what is your input? 100. What is the need of output? 300 volts, correct? Now we are comparing the reference voltage and actual voltage, that the 300 and maybe actual voltage is 290 for example. What is the error? 10. That 10 is given to the PI controller. In the PI controller we have to assign two gains, proportional gain plus integral gain. That means we are converting the unstable system into stable system. That means marginally stable system we are making with the help of PI controller. So that PI controller we have to assign Kp as well as Ka. For example, 0.1 and 0.01 is the value for Kp and Ka. This is multiplied with the error 10. So you will get the value of 0.1. That 0.1 is added with the initial duty cycle, that is 0.5. Correct? Now the duty cycle is from 0.5 to 0.6. So the 290 volt comes into 300 volt. This is the way the PI controller will work. But it's having a lot of drawbacks, PI controller. And it is the underdamped system. So and also it is second order underdamped system. So it's creating maximum peak overshoot issues, rise time, fall time, settling time. So after 0.5 or 0.7 or 1 second only, the voltage will come to settle. Before that, 10 to 20% oscillations will be there. 330, 350, then 200, 250. After that only it will come to 300 volts. So it's creating maximum peak overshoot issues simply. So now we have to tune the PI controller. So that's why it's require optimized algorithm, optimization techniques needed. So here I am concluding the converter and controller section. Next I am going to the motor side. Actually in the motor side there are two types, DC motor and AC motor. The combination of DC motor and AC motor is called as special electrical machine. So first we have to study about the DC motor. Under the DC motor there are two types. First one is separately excited motors and self-excited motors. So among these two and another three categories we know, DC series motor, DC shunt motor and DC compound motor. You take these three motors, the best one is DC shunt motor, correct? Because the in DC shunt motor both armature and field windings are connected in parallel. And the another name of the DC shunt motor is called constant speed torque curve motor. But anyhow, this DC shunt motor having windings in both armature system as well as field system. If you provide a constant DC supply to the particular DC shunt motor, the machine will not run because it's not creating the rotating magnetic field. We need RMF. So for that we have to use mechanical commutator. So the commutator is made up of stopper segments. It consists of slots and teeth only. It's like our teeth only, square shape. So if you provide DC current into the commutator, that commutator will convert the shape of the DC current into alternating current, square wave current. Now the armature flux and the field flux will link, then it will generate, it will create either torque as well as EMF. That is called the back EMF in motor and the supplied EMF in the generator side. Anyhow, this DC motor consists of mechanical commutator and another one brush. So what is the need of brush? Here commutator is also made up of copper and winding also made up of copper. If we connect these two, so definitely copper losses will come. That means spark will come. So in order to overcome the issues, here in the DC machine we are using carbon brushes. What is the use of carbon brush means? It is used to collect the current from commutator and this is then again we are providing it into the winding. So this is the use of brush. Now we have to think about the drawback of the DC motor. First one, commutator is additional weight. In both armature and field system it's having winding. Second drawback. And the final one, brush. It requires regular maintenance and the spark will come in the DC machine. So these are the drawbacks, but one good advantage is speed torque curve. It's a constant speed torque curve. Next one is AC motor. In the AC machine, synchronous machine is not a good one for EV applications. So asynchronous machine, induction motor is the best motor for EV application, conventional EV application, because the stator is a very good one for induction motor, but the rotor is very worst in induction motor. So for stator we are providing supply, that means we are applying 415 voltage. So what is the synchronous speed of the induction motor means immediately we will tell 120 FDP, but in gate exam they will ask a nice question. Suppose your number of phases is 5 phases or number of poles is 8 poles. So what is the synchronous speed? So our students can't give answer. So the formula for synchronous speed is total number of degrees. So 360 degree divided by number of phases. So 360 degree divided by 3 phase machines means it will come 120. Then that one for every 120 degree it is AC supply, correct? So frequency is 50 Hz. So 120 F into P. This frequency is divided, that means cut with the help of rotor pole. That's why 120 F divided by P. So the actual formula is 360 degree divided by number of phases into F divided by P. So this is the formula for synchronous speed. The induction motor never will run at induction this synchronous speed because of the winding, rotor winding only. If you supply 415 voltage to the stator, immediately magnetic flux will produce. In this flux there are two types. First one is the flux passing through the air gap is called useful flux, and another one is called the leakage flux. So due to the leakage flux, the maximum 380 voltage can induce in the rotor side. So the machine never run at 1500 RPM. So if it's run at 1500 RPM, that is not induction motor. So maximum 1410 RPM we can expect for the induction motor for 4-pole machine. And the biggest drawback, the rotor also having winding. So it will run during noisy conditions also. But the drawback, the commutator, it does not, actually the advantage, it does not need any mechanical commutator. With the help of AC supply, it's running. But the drawback is its speed curve very, very worst. It's creating regenerative braking, dynamic braking problem also. But the stator is a very good one. If you combine these two, that machine is called special, under special electrical machines, BLDC motor or SM motor, permanent magnet brushless DC motor or permanent magnet synchronous motor. So in the SM motor, almost stator and rotor is similar, but what is the difference means, in SM motor, permanent magnet synchronous motor, its rotor is cylindrical type, that means 180 degree polar machine. But BLDC is trapezoidal back EMF, it is projected pole, fixed type, salient pole construction. It's 120 degree polar machine, that is called a trapezoidal back EMF. If the machine is 120 degree polar, it's called as PMBLDC, and if it is 180 degree polar, that is called the PMSM motor. So compared to PMSM motor, the control of PMBLDC is very easy. But here in the PMBLDC, the stator is like a induction motor, but the rotor is like a DC shunt motor. But the difference, in the PMBLDC motor, the rotor is made up of permanent magnet. So definitely we should know the rotor position. So without knowing the rotor position, it's not possible to run the PMBLDC motor. Either you can use Hall sensor based or back EMF based, but without knowing the rotor position, it is not possible to run the motor. So I will tell the difference. Suppose if you take induction motor, you are going to apply some full voltage to the machine. At the same space, in the rotor side, the voltage will get induced, so the machine will run equally. Means the stator flux and the rotor flux will run equally. But in PMBLDC motor, it's not like that. Suppose rotor pole is near B phase, but if you are providing supply to the R phase, the machine will not run. So we have to fix 3 Hall sensors in nearby the stator, not rotor. 120 degree electrically as well as 60 degree mechanically, we have to fix the Hall sensor. For Hall sensor, we have to provide some 5 volt supply. So if you provide supply to the Hall sensor, immediately magnetic flux will form in the end of the sensor. If any rotor conductor is near to the sensor, immediately one EMF will produce. That EMF is called Hall voltage. So with the help of Hall voltage, we can identify either first 3 sensors are there. Suppose you are getting the back EMF from the first sensor. Now we have to energize the particular phase. So in the back EMF detection based PMBL-DC motor control. Initially, we have to consider the PMBL-DC motor like a induction motor. So 120-degree based voltage source inverter we have to use. Then depends on the rotor position, we can energize the winding. So this is the construction of the PMBL-DC motor and equivalent circuit. So this is the voltage equation as well as the back EMF equation, and this is the trapezoidal back EMF. So 120-degree pole of the machine. So this is the forward and reverse direction control. In induction motor, if you want to reverse the direction of the motor, you have to interchange the supply polarity. Similarly for DC motor, but in PMBL-DC motor, it's not like that. Simply rearranging the logic sequences, we can change the direction of the motor. So for locomotive application, so it's very useful. That means reversing the polarity. So next one I will explain about the PV panel. So this is the PV system. The PV system consists of that means two material. First one is insulator and another one is the conductor. For insulator you have two choice, copper as well as our aluminium. So compared to copper, cost of the aluminium is very less. So in insulator side, either you have to use germanium dioxide as well as silicon dioxide. In India, silicon dioxide is cheap and best. That's why we are combining aluminium and silicon dioxide. So first one is insulator, second one is the conductor. That means aluminium is the conductor, sand is the, that means silicon dioxide is the insulator. If you combine these two, we can say this one is called semiconductor. The conductor will work at any time, at any temperature. Insulator will not work, but semiconductor at some particular temperature, that is called breakdown voltage or cut-in voltage. After the cut-in voltage, that insulator will work as the conductor or else it will be reversed. Depends on the positive polarity as well as negative polarity. So like the way the solar panel consists of two materials. If any temperature falls, immediately electrons will flow. That the creation of electrons, the flow of electrons is called the current. Inside silicon dioxide is there, that is called insulator. That means resistive material. The flowing the current that falls into the silicon dioxide, so it's creating V into electrons I into R. It is called V. This is the way the solar panel generating the, that means converting the sunlight into electricity, but due to the temperature and intensity variation, you cannot get a constant output voltage from the PV system. So this is the PV curve as well as IV curve. So it's not possible to maintain constant. If temperature varies as well as intensity varies, immediately the output voltage as well as output power of the solar panel will increase or decrease. It affects the system, overall system. So these are the drawbacks of the PV system. So in order to overcome these issues, we have to go for DC to DC converter. So in this section, I will explain about three types of converters. The first one is interleaved interleaved SEPI converter, and another one is interleaved loop converter, and finally the combination of these two, interleaved KSK converter. So I have given my name only KS Kavin, so it is called the KS converter. So first I will explain about the interleaved SEPI converter. So what is interleaved? So in input side, you have to use only single input source, but in output side you can double the output voltage. For example, what is SEPI converter means? Single-ended primary inductor converter. So compared to boost converter, the voltage gain of the conventional SEPI converter is 1:8, but the normal boost converter 1:1.5 only. So cumulatively, this SEPI converter, interleaved SEPI converter can boost up to 10 times. Suppose you are giving some 100 volt to the input to the converter, it can provide up to 1000 volt, but at the duty cycle 98%. So here my aim is, we have to limit the duty cycle within 55% or 60% of the duty cycle. The converter has to give the efficient voltage. So similarly, we are providing almost 100 volt, and I am getting around 300 or 400 volt with some 60% duty cycle in the SEPI converter. In SEPI converter, in the input side you can see both the L1 and the L3, two windings are there. These windings are making the input current as continuous. But in the output side, diode is there. So in the SEPI converter, output current is discontinuous. So it can give almost good efficiency. But the drawback, the only drawback of the SEPI converter, the output current is discontinuous. So what is SEPI means? Single-ended primary inductor converter. So this interleaved SEPI converter can work under two modes, either two individual SEPI converters as well as in output side. If you add these two voltage with the help of the C0 capacitor, you can add these two voltage. So during the daytime, you can fix the mode of operation. Either S1 should be work or S2 should be work, or cumulatively S1 as well as S2 should be work. Depends on your load requirement, voltage requirement, you can fix the voltage operation. For example, in a conventional SEPI converter, if you provide 100 volt and if you have to take 600 means 600 volt output means you have to maintain almost 85% duty cycle because only one switch is there. Now same requirement, each switch should work only for 52%. So the lifetime of the particular converter or particular EV system will increase, and these two converters are two inductors are sharing the current. So the average current flowing through the overall circuit is decreasing. So this will avoid the firing problem. So this is the advantage of the particular SEPI converter. But from the SEPI converter, I am telling the only drawback is output current is discontinuous. So these are the mode of operation, how it's working. I will provide this PPT to the college. So if possible, kindly you can get the PPT from the college management. So this is the design equations of the SEPI converter. And the next converter is called interleaved loop converter. So this is the structure of the loop converter. Here the input side two switches are there. So in the loop converter, input side two switches are there. So we can expect discontinuous input current operation. But in output side you can see inductors are there. So this makes the output current as continuous. In the loop converter, input current is discontinuous, but in output side, output current is continuous. Here also it will provide high efficiency only, but the drawback still input side, the current is discontinuous, so this is also affecting the overall system. So similarly, you can fix either simultaneously or separately, we can work the loop converter, two loop converters. So this combination of this converter is called as, I developed the converter, interleaved AICTE converter. Here you can see in input sides also inductor is there, output side also inductor is there. So definitely it can maintain the both input as well as output current as continuous. So in the converter side itself we can expect more than 95% efficiency. I am not talking about the FDP algorithm. So only I am telling about the converter side. And also the voltage gain of this interleaved AICTE converter is almost 1:16 times you can get it. SEPI converter is 1:10, loop converter is 1:12. This AICTE converter is providing up to 1:16 times. That means that around 40 volt to 60 volt input is enough for series connection. That means number of panels should be 5 to 6 panels. Set of panel is enough to give the power to the that means we have to connect it in series, and the remaining n number of panels we can connect in parallel. So the load requirement we can satisfy it. Then internally one diode is there. This diode is preventing the switches. You take any converter, either in input side diode will be there or output side diode will be there. Here this diode will block. If any return current comes, that means it will provide the dV by dt protection as well as the di by dt protection. Internally, protection circuit is there, so it's reducing the EMI problem. And here the inductor is it's normal. It's not a normal inductor. We are using isolation transformer as the inductor. That means in isolation transformer, galvanic isolation is there. So we have to connect both the primary winding and the secondary winding in series. Both are separated. That will work as a transformer. If you connect these two in series, definitely number of turns N1 plus N2 is equal to N. So this is the way this converter reducing the electromagnetic interference problem also. And the duty cycle of this proposed converter just 52 to 54% is enough for even three-phase supply also. That means if you want to maintain 600 volt DC, just 54% of the duty cycle is enough to maintain that the constant DC voltage. So this is the mode of operations. And the control of the converter. So first one already I told about the PI controller. So these are the drawbacks. So maximum peak overshoot problems are there. That means rise time, settling time, fall time, dead time. So many problems are there. That is called internal error. It is creating absolute error. So we have to avoid the problem. So we have to go for optimized PI controller. So the objective function of the particular work is we have to reduce the error. That means here you can see, for example, reference voltage is 300. After some second only we are getting 300 volts. Correct? Before that particular time the voltage is increasing and decreasing. It's an unstable system. We have to convert into the unstable system into marginally stable system. So we have to tune the PI value. The first PI tuning method is called the conventional one. So second, we have to go for optimization technique. So under the optimization technique, so many techniques are there: PSO, DWO, then whale optimization, Class-Trapper algorithm. So n number of optimizations are there. But in this work, I am discussing about the two types of optimization. First one is basic PSO, particle swarm optimization, and another one is DWO. So this is the main flow of the particle swarm optimization. So I will tell the story for optimization technique. What is the need of optimization and how this is working. So initially the reference voltage and actual voltage both are compared and the error is given to the PI controller. For the PI controller, so through trial and error method we are assigning some KP and KI value. Because of this error, oscillatory duty cycle will come. That means oscillatory reference signal is generating from the KP and KA, and it is compared with the carrier signal, and you will get oscillation with the duty cycle that affects the output of the converter. So in order to overcome the problem, initially we have to tune the KP and KA value. So that can be achieved with the help of two methods. First one is offline tuning and another one is online tuning. For online tuning, you need FPGA controller, 10-bit FPGA controller, VLSI processor, as well as MATLAB simulating circuit, MATLAB software you need it. For offline tuning, no need. So with the help of MATLAB coding, we can generate the KP as well as KA value. So what is objective function? General objective function means V reference minus V actual into KP into KA is equal to 0. That means you have to compare the reference value and actual value. Any error is there, we have to multiply with the PI controller. That PI controller value should reduce the error. So now reduce the error means we have to go for iteration method. That's why for electrical engineers we studied about the numerical methods. Gauss-Seidel methods, Newton-Raphson methods are there. Like the way number of iterations we have to do. So some optimization took more time convergence is high, but some optimization will provide results very quickly. So particle swarm optimization will provide the results very quickly, but still some oscillations will be there in the output. But in the GW algorithm, Gray-Wolf optimization, same objective function, only the equations will be varied, either alpha, beta, gamma, or ABC parameters. So every optimization having a different objective function. So that is the difference. But all the flow is same only. So this is the common step. First we have to initialize the size of the population, then we have to assign the initial duty cycle, the number of iterations, then we have to compare the reference and actual. If the error is there, then we have to update the P best and the G best. What is P best means? It is KP value, G best means KA value. So under some 50 iterations, within 50 iterations, almost we will get 0 error. So that particular G best and P best is fixed as KP and KA value. So in this work, number of iterations conversion I assigned 50 and the initial duty cycle is 0.5. Reference output voltage is 400 volt. So this is the tuned Kp and Ka value. So convergence time 1.2 seconds. So after 1.2 seconds, we are getting some proper value. So next one is the GW algorithm. So same, only additive function will vary. So same algorithm, but additive function will change. Here in GW algorithm, we will get reduced amount of second order underdamping problem, but the convergence time is slightly high compared to the PSO. So if we combine these two, you will get one hybrid algorithm. So in this work, I have combined the two optimization, GW for best result, PSO for reducing the time convergence. Within 0.9 seconds, we are getting the tuned value. So this is the advantage of the hybrid optimization. So like the way if you are doing research, so you have to take two good optimization algorithm. One should satisfy the time convergence and another one should satisfy the error convergence. So next one is the grid synchronization. So what is the need of grid synchronization? So for inverter, we are providing either 300 volt or 400 volt DC link voltage. If you convert this DC link voltage to one particular modulation index, you will get exactly 230 volts. But the problem with the grid, it's not possible to get exact 230 voltage in the grid. So here parallel connection is there. That means we are connecting parallel with inverter output and grid output. So here we have to satisfy three objective. First one is phase sequence should be same. It is single phase, so no problem. Three phase means you have to satisfy the phase sequence, frequency and amplitude. In single phase, almost you will get around 49.99 to 50.01 percentage, frequency, but amplitude variation will be there. So we cannot control the grid voltage, but we can control the inverter output voltage. Correct? So first we have to this is actually bidirectional grid synchronization. During daytime, the PV output has to give to the grid. During night time, from grid we have to convert the AC voltage into DC. How it's possible with the help of IGBT or MOSFET? In the SCR thyristor, we studied from 0 to 90 degree firing angle, that is called rectifier, rectification mode. During more than 90 degree to 180 degree, that average duty cycle, that means firing angle, that particular device will work under inversion mode. That is the difference. So initially, we are generating the PWM pulse for the inverter sinusoidal PWM technique. That means we are comparing the carrier signal and the sine wave. You will get the sinusoidal PWM. That pulse is given to the inverter. So during the daytime, that inverter will convert the DC into AC because of SPWM. During night time, instead of sinusoidal PWM, we have to apply the multiple PWM technique. That means reference signal is DC. So this PWM is given to the inverter. That means the duty cycle will be, that means angle will be more than 90%, less than 90%. During daytime, we have to work for 180 degree. Correct? In inverter, there are two modes of operation, 120 degree mode of operation and 180 degree mode of operation. That means more than 90 degree means inverter, less than 90 degree means rectifier. So during daytime, we have to increase the modulation index more than 90%. During night time, we have to keep the duty cycle. So in this section, always you can get AC voltage or you can apply AC voltage. But in this section, that means both collector and both emitter is there, na, plus and minus. There you will get always DC link voltage. So with this concept, we have to achieve the grid synchronization. First, we have to measure during night time, we have to assign the reference DC voltage and we have to measure the actual voltage of the capacitor bank, not the converter output, capacitor bank. That error is given to the particular normal PI controller. We didn't use any optimization because for grid synchronization, we have to provide earliest possible. So it's no need to use any optimization technique, just the PI controller is enough. So we will get reference signal. that reference signal we can compare with the carrier, that error is given to the inverter, that particular circuit that will convert the AC supply into DC. But during daytime, you have to measure the reference real power, you have to assign the reference real power. Suppose, for example, your total power is 10 kilowatts and your motor, EV motor is 3 kilowatts, then among the 7 kilowatts, we can give up to 5 kilowatts to the grid. That is the reference. Actual power you can get from the grid. We have to measure the real and reactive power. That error we can take from the error. We have to use some PI controller. That the PI controller will create a sinusoidal PWM with the help of sign modulation. That is combined, and the error is sign PWM that is given to the inverter. So inverter will convert the DC into AC. So this is the bidirectional control of or grid synchronization of the inverter system. Next one, so FPGA controller. So what is the need of this controller? In simulation, all of them can develop the circuit, but the hardware is the very important one. Correct? Research project should be converted into real-time project. So for that we need controllers. So in controller, microcontrollers are there, digital signal processors are there, and finally VLSI. So the microcontroller operating frequency is 10 megahertz to 40 megahertz of operation. That means in microseconds. In VLSI processor also microseconds, but this FPGA controller works up to 150 megahertz. That means 10 power minus 10 seconds. Very large scale integration system. And the power supply scheme for digital processors as well as microcontrollers are called the TTL family, transistor logic family. So it can work up to 5 volts, but this FPGA controller comes under CMOS family. So the operating voltage of the FPGA controller is 3.3 volts only. Next, microcontroller pins. Maximum 40 pins are available in the DSP controller. Here in FPGA controller, 357 pins are there. It depends on the FPGA controller. Some controllers having 127 pins. Anyhow, in the microcontroller, you can generate 6 plus 2 PWM pulses. Maximum you can generate only 8 PWM pulses from the microcontroller and 10 PWM pulses from the digital signal processor. In the FPGA controller, you can generate up to 100 PWM pulses. So if you use microcontroller, you have to use 3 microcontrollers for this particular project. But if you use FPGA controller, high speed of operation is there and only single controller is enough to produce the PWM pulse. And this FPGA controller comes under control circuit. But our inverter, converter comes under power circuit. In power circuit will vary, the working voltage may be 100 volt, 12 volt, 1000 volt, even 11 kV also. But my controller, maximum operating voltage of the controller is just 3.3 only. So we have to isolate these two devices, control circuit as well as power circuit. That is achieved with the help of this driver circuit, TLP250. It is a combination of optocoupler. So optocoupler is the combination of photodiode and phototransistor. So in between this photodiode and phototransistor, only light connection is there. There is no electrical connection. So it will separate the ground as well as it will amplify the 3.3 volt PWM into 15 volt PWM, because the operating voltage of the, that means gate voltage of the MOSFET as well as is equal to 15 volts. So we have to amplify it. So this is the results and discussion part. So here in the interleaved KSK converter, so only I have connected 4 sets of solar panels in series and 7 sets of panels connected in parallel. That means 4 number of panels are connected in series. Like the way 7 sets are there. So here compared to NS, NP is high. And for maintaining 400 volt output, input here I assigned 81.87 volt and the duty cycle is 0.521. In this work I used the device, switching device is IGBT. The maximum operating frequency of the switching frequencies of the IGBT is 20 kHz. For safer side, I maintained 10 kHz. So then calculation of the L1, L2. For SEPI converter and the loop converter, so more than 10 millihenry will come. But in the this proposed KSK converter, just 0.775 millihenry is enough to boost the particular output voltage. And here you can see the filter capacitor. So nowadays the boost converter required 4400 microfarad as well as 4200 microfarad for storing the output voltage as well as reducing the ripples. Here I used only 100 microfarad only. That means the size of the capacitor also reduced. The compact size you will get it. So this is the overall specifications of the system. The similar screenshot. The post converter design. This is the motor control. This is the inverter side control. So I have tested the converter with the constant parameter as well as variable parameter. So here initially 30-degree temperature and 950 intensity is there. You can see the output voltage. Here you can see the current. So input current is continuous. It's not going to zero. Similarly, this is the output voltage of the particular converter. It's having maximum peak over tissues and the oscillations are there. But in the final side, so compared to the normal one, this one, so we are maintaining almost 400 volt DC and there is no maximum peak over DC. This is the advantages of optimization. And this is the output current. Here the output current, here also is not going to zero. So in this converter, both input current as well as output current is continuous. This is the way, if you are doing any SCA paper as well as PhD work means, in EV application you have to combine two converters as well as if you are designing a new converter means definitely the input current and output current should be continuous. Then only you will get good efficiency based converter topology. So this is PMBLDC motor side. You can see with the conventional PI controller, I am getting the settling time is around 0.001 only. So immediately it's getting settled because of the optimized output only. Here the torque ripples also very less. So this converter maintaining continuous output current. So in the PMBLDC motor, no need to go for additional torque control topology. This converter alone will reduce the torque ripples. And this is the performance of the grid system. This is the grid voltage and grid current zoomed view. Real power is high, reactive power 10 power minus 4, so almost 0. Test case. So first we are providing the voltage from PV at 0.3 seconds. I am cutting off the PV panel. So immediately you can see the output voltage of the PV, it comes to 0, current comes to 0, but you can see the output voltage. From the grid it's providing DC link voltage. There is no voltage reduction. So because some of them will ask, if you remove the battery, how it's possible to maintain constant DC link voltage? So I have proved here. If you use battery converter also, that will take some time to convert into the, that means change into the buck mode into boost mode. But compared to the battery converter, this grid synchronization is very easy. So this is grid side. So during the, it's providing power. So reactive power is high. It is actually 1 HP, but the BLDC motor is taking around only 150 watts. That is another added advantage of the PMBLDC motor. So with the minimum amount of power, the machine will run efficiently. So here there is no variation. So we removed the input supply, but even though the electric vehicle is running very smoothly, even at 0.3 seconds there is no distortion in the speed. So the machine will run very neatly. So and the total harmonic distortion, we are taking the power from the grid, but even though the total harmonic distortion is 1.98% only, the voltage harmonics is 0. The current harmonic should be less than 5, it is satisfying 1.98%. So at 0.3 seconds, the interleaved KSK converter is, compared to other converter, it is best. It's the dV by dt protection. It's providing good dV by dt protection. Here you can see in the positive side, during the 0.3 seconds, immediately the input side voltage is increasing. That means the dV by dt problem is there. Back EMF problem is there. But in the KSK converter, we block that. So this is the hardware setup. So I am providing 124 volt almost. So up to 80 volt is providing constant 400 only. During 0.5 at the 0.5 to duty cycle, we are getting the exact output voltage. So this is the PLDC motor current waveform and the trapezoidal back EMF waveform. So this is conventional PI controller. So in the motor speed waveform, slight maximum peak overshoots are there. And this is the voltage and the current waveform. So in hardware, the total harmonic distortion is 2.3% only. So compared to other converters, so this proposed converter is giving around 95.4% efficiency. So for EV applications, the best hardware part is FPGA controller only, and the motor side either you can choose PMSM motor or PLDC motor. Compared to PMSM motor, PLDC motor is best one because for PMSM motor you have to go for Park and Clark. That means the DQ transformation we have to go to solve the PMSM motor. For this PLDC motor, only Hall sensor signal is enough. With the Hall sensor signal we can run the motor. So this is the way by achieving good electric vehicles, renewable based electric vehicles, we can make our cities into smart cities, and after 25 years, so definitely all the road transport will close. So with the help of bus bar, that means like a transport EV, means electric traction transportation system, definitely bus bar will come in the roadside. So with the help of collectors, all the cars as well as buses will take power from the common grid, and you can generate the power from the PV system, and we can give to the either EV as well as household application. This is the way I am concluding the today's section. Tomorrow afternoon I will go with the battery management system as well as machine learning applications for EV applications. So thank you so much. If you have any doubt, kindly ask me.
Good evening, sir. Nice presentation. It is very clear, sir. I could understand that how much you are very clear with the basics, which are very much necessary for today's generation. So actually, at the interest of the EVT students, sir, can you join only for this year? Can you suggest a problem statement so that the students level, from the first year level BTech, they can work on? Because they are new to this, I wanted to give some problem formulation since you are achieving all the basics and also research part. So you can suggest a problem statement, sir.
Okay, ma'am. Better you can take the EV converters and you have to combine the machine learning activity.
Okay.
Converter with the machine learning activity.
Machine learning, okay. So machine learning activity, okay. Okay, sir. Thanks a lot for your time.
Thank you.
Kavin sir, can you please start the presentation now?
Okay, sir. Okay, thank you.
Okay, thank you, sir. Nice presentation, sir.
Thank you, sir.
Participants, any feedback? Okay, sir, let us conclude. Thank you very much, sir.
Thank you, sir.
Your valuable insight and informative session. Your expertise and practical knowledge have provided us with a deeper understanding of the topic. The examples and real-world application you share were very engaging and will surely help participants apply this concept in their professional work. We sincerely appreciate the time and effort you took to make the session so enriching and interactive, sir. Thank you very much.
Thank you, sir.
We will tomorrow, sir.
Okay, sir.
Okay. Sir, participants.
Can I request to, actually I request to turn on your camera. First we should. First is the request to turn on your camera first, please, sir.
Sir, someone presenting the screen, sir. Sir, Mohammed Salim, sir, can you now? Yes, thank you. Participants, can please turn on your camera. Okay. Okay, thank you. Thank you. Thank you, Kavin, sir.
Okay, sir.
Thank you. We will meet tomorrow, sir. Bye. Okay, sir. Thank you. Thank you. Sir, Salim, sir. Good evening. Stand on your mic, sir. Yes. I think your mic is in off condition, sir. Please turn on.
Correct.
Sir? Yes, yes, no problem. Sir, Salim, sir, can you check your audio? Yes. Yes, yes.
Can hear.
Okay. Thank you, sir. Thank you. Magendran, sir? Magendran, sir? Sorry, online. Magendran, sir? Sir? Give, sir, give me a minute. We will. Sir,
Unless Mahindra is in line making.
The ma'am, wait, ma'am, there is a network issue in Mahendran. It's returned back to 5 minutes.
Good evening, sir.
Yes, sir, yes, sir. Okay, thank you, thank you. So now, okay.
Good evening to all the respected deputies, faculty members and the participants. It's my great honor to introduce our resource person for this faculty development program and autonomous mobility and digital infrastructure for future ready cities, Mr. Ubayadullah Muhammad Salim. Mr. Salim is an alumnus of AICTE College of Engineering, where he earned his bachelor degree in instrumentation and control engineering, affiliated to Anna University, Chennai. Over the past 12 years, he has built distinguished career in the field of automation, semiconductor industry, and building services engineering. Currently, he is serving as a project coordinator at FDP Engineering Private Limited, Singapore, where he has been associated since 2012. His expertise covers building information modeling, MEP system coordination, automation control system, and digital project integration. He has played an instrumental role in several prestigious projects in Singapore, including NS Square at the Marina Bay, Senkang Central Smart Development, the New State Course, and the Tanjung Packer Center, the tallest mixed development in Singapore. With his strong technical background and the international project experience, Mr. Salim embodies the essence of how digital infrastructure and smart engineering practices are shaping future-ready cities. And today he will be delivering a session on smart waste and water management systems, a topic of great relevance with sustainable management becomes a cornerstone of urban development. We are truly proud to welcome back our alumnus, and it is indeed a privilege to have him as a representative of this program. Ladies and gentlemen, please join me in extending a warm welcome to Mr. Ubayadullah Muhammad Salim. Welcome you, sir. Thank you. Sir, kindly take up the session, sir. Sure. Good evening to all. This is Muhammad Salim. You can see my slides, sir.
Sir, but your slides are not in presentation mode, sir. Your slides are not in presentation mode. Sir, if you go back to your Google Meet presentation mode, click entire mode, sir. Click entire mode, after then come to the slides. Yeah. So, is it so go back to your slides, sir. Please. Sir?
Yes.
Just switch on your entire screen mode in Google Meet. After that, just minimize your Google Meet account. After that, you open your PPT. There is a network issue, I think. Okay. Now turn on your PPT, sir.
Now consider.
Yes. Now, yeah, it's fine. Thank you.
So, today we will go through today what is the smart waste management. And also we will see what are the countries using the smart waste management, and also we see the few examples of the technology used on the smart waste management. First of all, we go on the innovative smart management system technology. In some countries, they're using like smart bins and also like waste level sensors and also AI recycling also. Usually, if the smart bins, right, they will install like a different level of segregation of the smart waste. For example, it's like paper, bins, stuff, and all they can sort it out using the smart bin technology and also having different colors. When you go to the waste level sensor, they will installing like a overflow of the waste of the bins. For example, if these bins having a certain level, it will indicate you cannot fill in the extra wastages on inside, and also it will avoid the unnecessary trip from the landfill to maintain the proper arrangement between each truck and come and pick all the loads and all everything. When you take on the AI side, they will have the AI robotic technologies and also using this technology to separate the wastage. For example, the same case, what doing the smart bins, right? Smart bins is actually they will segregate using the individual color code. But with the AI, they will have an automated system. They can separate the fields and all that. Then, if you see the implementing of smart waste management in various cities, for example, San Francisco, they're using the AI robots to recycling the waste materials quickly. When you see on the South Korea, this country already deploying the dust-free waste management and also the installing underground pneumatic waste pipe in order to collect all the wastages through a pneumatic system. If you check, like for example, in Amazon, they are installing like public bins with the smart sensors like IoT sensors. They can easily collecting all the information from the smart bins also, like the loading and unloading. For example, if you see on the working mechanisms on the technology, the first one is the waste disposition. The waste disposition will identify the automatic recycling of the waste types like papers, stuff, things, metals, and all other things. Then when you go to the second item, it's like segregation of waste materials. This will help on occasional cleaning and also facilitating of optimal handling of the recycling wastages. Then if you go on the information on different types of wastages, for example, the quality of waste, the waste disposable habit, and the storage. This quality of waste will be considered as either it's a human waste or animal waste or any medical waste, but also this will be decomposed in a different manner. This one can be used for recycle and reuse also. Then next one, if you check on the fourth item, is the smart bin. This will This technology actually using in many countries, and then the notification on the capacity, whether it's fully loaded, or half loaded, or partial loaded, let the truck drivers will get the notification, and also they will do the arrangement of collecting the wastage in a proper manner. Then if you check on the item 5 and 6, they have a applications. This will give the trend loss of the data stored, how much tonnage they collected for this year or this month or these days. And also they have the proper management system on the applications. Then if you see on the IoT technology, this will actually provide the real time on the capacity of it will give the capacity of the smart wastage building. For example, they have every bin have a different individual RID tag and also the sensors and the GPS monitoring. This RID tag will separate the collection point, and also they have the sensors which it's capable of sending like how much capacity and the weight and the temperature on the bin. For example, if it is during the hot sunny days or raining time or anything, they can easily monitor the temperature, and also they can trace back during the climatic changes and all that. The GPS will guide the real-time collection information on which truck is nearer. It can be easily go and collect all the information. Next one we see on the benefits of deploying. Usually the benefits you see effective on the work, and also the cost efficient. You can manage the cost efficient like implementing on more number of smart bins, and also it's eco-friendly to the people, and also the climatic changes also it will solve. Then it will reduce the CO2 emissions, and also sometimes if you have reduced the human manpower, also it can be reduced due to these smart technologies. These are the future outlooks on the smart energy. For example, it stops smart waste management for like a Palo. They're doing the monitoring filling level of trash cans, and also they will provide the real-time information. And also this will reduce the greenhouse gas emissions. If you check on the pneumatic waste pipes, this pneumatic waste pipe actually they installing in the public waste bins, and also this will cut down the harmful gases or any emission from the trash bins and all. This can be resolving. When you see the e-wastage kiosks, actually this e-wastage kiosk is like installed in most places like eco-friendly ATM. If you see the e-wastage, for example, sometimes they have unwanted usage of like not usable electronics items. You cannot throw any else in the common place. This e-kiosk will collect all the unwanted usage electronic purpose. Then they can check whether this one they can be used for recycle purpose or reuse purpose, or really they cannot use it for any other purpose. These are the real-time monitoring smart waste systems. Like for example, just as I mentioned, each bin has the different RFIDs. Like for example, it's like ST0045. Then this will indicate how much the level of the wastage is filled in on the trash bins, and also you can see the area of the input. This one, for example, if it is in Texas Austin or South Dakota, this will give the clear information for the truck drivers to collect which one to take precedence to go and collect the waste material from the smart bins. These are all another framework from the smart bins, how the smart bins which work to overstopping the overflow of the waste bins, and also the routing algorithm for the truck to find the shortest way to collect the information, and This will help on reducing the fuel consumption and also the real-time database for monitoring the process. The smart waste arrangements were used in various sectors. For example, the most of the smart waste is come from the municipality side, followed by the universities and colleges. Then will be construction sites and also from the food and waste industries, healthcare and manufacturing sectors. So this will tell you how much wastage is produced for every sector. For example, if we see the case study on garbage management, like Sweden, they already implemented the IoT sensor in public things to improve the collecting waste collection on the common places. This will integration of the IoT sensors in each smartphones, and also they can have a real-time database like that I explained earlier. It will tell you how much is the collection is done on this individual bins, and also this will optimize the wastage collection process also. So here you can see some of the examples of the bin spreadsheet, like how much is the stamp fees, and also it will tell you the status also, like this one you need to be emptied because if the green signal is there, they need to be emptied because it's going to reach 100% also. And also there is another sign like showing like equal above to going to reach 160. They have different value range from 60 to 80 or 90 to 100 about. They will do the different percentage on collection of the wastage. This is the dashboard. You can see how the system is worked. For example, today how many sites they go and how many drivers they did the work with how many vehicles, and also who is the user and which location they go. They can easily trace and manage per day how many locations they go and do, and also for easy management of the collection and also the delivery the wastage to this one is another improving technology and the optimized route. For example, you can see how they can go and select from the 8% to 80%, but also which one takes the precedence to do the analysis and all that. This one is the market size of waste management system for the future development. If you are planning for like 10 years, 20 years, what will be the growth on solid waste and special waste and also the e-waste. So this will tell you on the real-time consideration on the waste management. This one you can see the working architectural drawing for the smart waste management using the GPS and also the collection based on smart IoT sensors with different color codes with different types of materials to be collected. If you see the waste management framework to decrease the carbon footprint, we have to go with step by step, like collecting the information of the ultrasonic sensors and also using a GPS technology to track the collection points of each bin location, and also align the sensor volume and the disposal procedure, allow the smart and intelligent collaboration with each device. Then we'll do a corrective measurements in case if you want to do any replacement or anything. Next, we move on to the water management. The main thing on the water management is like conservation, sustainability, technology, collaboration and regulation. Conservation, you have to take on the reduce water wastage and improve efficiency. On the sustainability, we need to think of ensure like long-term water supply, for the eco-friendly practices. when we take on the collaboration, we need to engage with different parties and also be responsible on water usage also. When we go to technology side, the smart system is monitoring the real-time usage and the resource tracking. The regulation implements the policy ensures with equal water distribution and water usage. When we see the current challenges in water management, like climate changes, these climate changes increase variability in weather patterns, affect the water availability and the quantity also. For aging infrastructures, many systems like getting outdated and also like respiratory pipes, like very old pipe and the facilities also. Like water quality, pollution from various sources, supplying clean water, supply for the community, like public awareness, like sometimes the insufficient education on water conservation will make the people to do the over usage of water, also wasting the water, not properly managed to store the water also. In order to avoid this one, we are introducing the advanced technologies like smart center, data analysis, automations, and IoT interaction. Actually, the smart sensor will play a major role in like real-time monitoring and improve how the water efficiency, water usage efficiency. The data analysis will tell you on decision making for the resource management on which location need to use more water or which location don't need to use more water. The automation system will reduce the human error in order to monitoring the water operations and all of the things. We can introduce another good water management is like irrigation techniques. This one irrigation techniques actually used on like many places in many countries, like crop building, saving water, and also cost efficiency through a good water management. The water conservation techniques and strategies like you can use on the irrigation, utilize the advanced system on the optimal water usage, like rainwater. Usually countries like Singapore, they will use the rainwater storage and also like they will create a reservoir to store all the rainwater for the future usage. In some countries, you can use for like agriculture and domestic usage. The recycling controls involving treating the wastewater or reuse in various processes. Things like in Singapore, they are actually using the recycling waters is used for drinking purpose and also in various usage also. Then we can give the proper education on awareness of water saving techniques to all the people. Innovations of water treating solutions like natural systems, advanced aggregation, the membranes, the bioreactors, decentralized treatment, resource recovery, and smart monitoring. Actually, the smart monitoring you can use as a IoT technology for the real-time database and treatment process. Resource recovery extracts useful information like phosphorus, useful material like phosphorus and biogas from the waste. If you get on decentralized treatment, usually local system for small habitats and remote areas, like membranes, bioreactors, integrated on biological treatment with membrane filtration on for efficiency. Our solution is to remove the complex organic components. The strategies for sustainable water usage like reuse the great water system for irrigation and non-potable usages, and also the rainwater harvesting system for the land watering. Education, conduct a community workshops on water reservoir technology, efficiency, adapt the water efficiency facilities in residential and commercial buildings, monitoring, install smart meters to track the usage minimize the waste, and also like regulations enforcing policies that encourage sustainable water management practices. Public awareness education campaign, you can turn the water saving, the public awareness and conserving water at the home, community workshops, like organize a local session focus on water treatment practice, and also like some schools they can implement the educational programs on how the sustainable water will be used, and also you can do online those resources also. The best practice for emergency water management, like regularly accessing water source and infrastructure from reliability and risk. Conduct training session on staff for emergency protocol and procedures. Collaboration, like you have to manage and collaborate with the local authorities and organizations in case of any disaster response efforts, like proper storage, ensure that adequate storage for emergency water supplies on immediate access. Then the real-time monitoring, I already highlighted, like real-time monitoring, like you can install the various IoT sensors to monitoring. Then establish proper communication channel between the relevant authority parties. Then the final conclusion on the future direction is sustainable practice. Adopting sustainable practice is crucial for future water resource management, but also community engagement, integrated approaches, climate adaptation, policy research, technology use. Thank you for this opportunity. Any doubt can ask.
Participants, any feedback? Sir, in Singapore,
Yes.
how water will be saved and in smart way, sir?
So, for example, like in my project, like now we are doing the project. Now we have like some type of ways they have to. For example, if you use the shower, then the people in the common place, the shower, the people forget to closing the tap. Then how this water has been stopped from wasting. Then we give some suggestions to the client side, and also like you can install either like using the motion sensor. If there is no people on that, it will give you the suggestion to the BMS building management side, like this area there is no people, but the water is flowing few minutes. Or you can do settings also like 20 minutes or 15 minutes. If there is no people or physical or anything, if the water flow exceeds 20 minutes, it will give the alert to the building management system like this water is wasting unnecessarily. Can someone go and turn off the tap? And also like few places they will build like reservoir and all the tunnels, all the rainwaters will be collected and stored in a reservoir. This water will be used for recycling purpose, and also it's distributed to all the developments and also the HDB flats. But they convert into a drinking water and also like unusable, like potable water also.
Okay, sir. Thank you. Sir, next thing, waste management is waste management.
Waste management also, students will adopting the waste management by every HPV work, like flats and all, they will do ownership, like collecting all the wastages, and also every 10 HPVs or 15 5 HPVs, they will create a recycling, recycling waste management pressure. This pressure will collect all the wastage from each blocks and houses and everything. Then they will crush. They will bring it to the yard. Then they will lay it as a floor for future purposes. In case if it is organic one, they will use for the organic purpose. If it is for non-organic, used for commercial purpose, they will send it to the commercial purpose for future developing of the groundness and all that. They can use as a like pre-test using state walls also.
Thank you, sir. Participants, anyone?
I'm Surya Prabha, sir. Am I audible, sir?
Yes, ma'am.
Sir, the session is very useful. It is very interesting, sir. Nowadays, this topic is very essential for us. It is useful and informative. Thank you, sir.
Because nowadays everywhere they were trying to use for like smart things in order to reduce all the unwanted wastage collection and all. Make the country more cleaner, green, more green and environmental. Because many places they have like certain greenberg points also. For example, in Singapore, they will have a gold platinum. They want to make more, reducing the carbon emission for the environment, make more food. That's the main motto is in
Yes, sir. Sure, sir. Sir, also in RO, we are cleaning the water, is it, sir? Excess of water, it is, we are wasting more number of liters in cleaning in RO, is it, sir? Shall we use the excess water?
No, actually here also they are using the reverse osmosis, but they will use the reverse osmosis water also, they will use the recycling for non-portable water, like in case of like fire engine, because if this water sometimes cannot use for drinking purpose. So they will use like commercial usage like fire engine, the water or something.
Any suggestion for the home, sir? We are wasting plenty of water. Any idea or suggestion for the home?
Let me check, ma'am. I will share the info.
Okay, sir. Thank you, sir. Thank you so much.
Sir, in Singapore, BSM, any opportunities for students, sir? BMS.
Currently, in Singapore, they are reducing the SPAS. Like usually, previously, when I come to Singapore, they have many chance of getting SPAS and all that. But currently, in Singapore, actually, everywhere you can see the building automation and also BMS monitoring system. In construction sectors or the facility management, they are using the building management system. There is a lot of opportunity for the building management system in everything, not only in construction sectors, and also in automation side, and also in the shipyard side, everywhere is building management.
Yes, sir. Thank you. Sir, anyone? If you have a problem in network, please type in chat box, ask the question now. Sir, anyone? Please.
Yes, ma'am.
If we implement the smart test management in our college, how much we have spent for that? Any approximate cost?
Actually, it depends on your implementation. First, implementation location you're going to implement and all. For example, it's like government places or particular areas and all. It depends on the person.
Okay.
But if you are
Not a big
no, actually it depends. Like if you want to make more green, like a knowledge environment, it's a suggestion to implement all the smart things and all that. Then you can easily have the proper management of the wastage.
Yes, sir. Okay. Okay, thank you. Sir, good evening, sir. Anything you are specific about e-waste management, sir? Because I handled one subject, but by the time when I came to know what are the different protocols we are following, we don't have much authorized person to handle the e-waste. As far as the simple is concerned, it's just like what, how they are managing the e-waste.
They will use this erase for proper storage and sometimes they will use for gas and all that.
Ma'am, now conclude the session, ma'am. Shall I? Sukshar? Shall I conclude? Okay. So, thank you very much, sir, for delivering such a enlightening and thought-provoking session. Your extensive knowledge, clear explanation, and real-life example have greatly enhanced the participants' understanding. Okay, sir. We sincerely appreciate your time, dedication, and effort in making this session highly valuable for the FDP, sir. Thank you. Thank you. Thank you very much. Participants, tomorrow's session will start in 2 p.m. Yeah, last day for this FDP session. So tomorrow start with 2 p.m. All of you. Don't forget. The session will start on 2 p.m. So anything else, sir? Ashok, sir?
Okay, sir. Sir, actually, my
Yes.
that time I was asking question, what answer sir answered regarding the investment management in Singapore?
Okay. Ma'am, expert is relevant session. Please mail me your account, ma'am. I will transfer. Okay.
Okay, sir. Whatever he answered, you just use possible text, sir.
Yes, ma'am.
Alex,
Yes.
sir.
Yes, ma'am.
I
Yes.
will come to your lesson chat, whatever he answered, because I got a call, so my line got cut, so I couldn't answer, like listen to his answer.
Okay, ma'am. Okay. I will share, ma'am. I will.
Could you please reply to WhatsApp? Thank you.
Okay, ma'am. Okay. Thank you. I will share, ma'am. Thank you. Yes, sir.
Tomorrow there is an online test up 8 to 9.
Yes, it's 1 hour online test in. I will share, sir. I will share, sir. Feedback link. I will share, sir. Sir, tomorrow the participants have an online test. After complete the 13th session, the test will be conducted. The duration of test period is 1 hour. So I share the link or website in after the 13th session, sir. Thank you. So all of you please join tomorrow 2 p.m. sharply. I will share the link now. Thank you very much once again. Thank you.
Thank you, Alex. Thank you.
As per